Hello. Hello and welcome to this video. This is the 45th set of problems on theory of equations and polynomials. We have solved till now 440 questions. Now we will solve 10 more interesting problems on this topic. The link to download the PDF will be in description, and you can watch one of the earlier videos. I have shown how to download it. Now, one thing you can observe if you have watched my previous videos is that the font is different. Earlier font was Computer Modern Roman, and now it is X Charter. So that's a bit of difference you might notice if you have seen the previous videos. So before we start with problems, I will say what I always say is that when I'm stating the problem, you should pause the video. And only if you cannot solve the problem, you should look at the solution. So without further ado, let's get started. Question 441 says that let alpha beta be the roots of the equation x square plus ax minus 1 by 2a square is equal to 0, a being a real parameter. Prove that alpha to the power 4 plus beta to the power 4 is greater than or equal to 2 plus square root of 2. So from this given quadratic equation, we have alpha plus beta is equal to minus a and alpha beta is equal to minus 1 by 2a square. All right. Once we have that, we can write alpha to the power 4 plus beta to the power 4 is equal to alpha plus beta whole square minus 2 alpha beta. Now this whole thing is squared minus 2 alpha square beta square. You substitute a for alpha plus beta and alpha beta, you get 2 plus a to the power 4 plus 1 by 2a square, 2a to the power 4. Now we let this is equal to y. Okay. So once we let this is equal to y, we have got 2a to the power 8 minus 2a to the power 4, y minus 1 is equal to 0. So because the parameter a is real here, we can say that the discriminant would be greater than or equal to 0. So y square minus 2 greater than or equal to 0. Now this means that y is greater than or equal to square root of 2 because a to the power 4 greater than or equal to 0, and from this we can deduce that alpha to the power 4 plus beta to the power 4 greater than or equal to 2 plus square root of 2. Now you will ask me how we arrived at this. So we have got this y here. Now y is greater than or equal to 2, we substitute here because this is what we took as y. So 2 was there and now we put square root of 2. Now we move on to question 442. It says that if alpha beta be the roots of the equation x square minus px plus q is equal to 0 and alpha beta both are greater than 0, then find the value of alpha to the power 1 by 4 plus beta to the power 1 by 4. So clearly alpha plus beta will be p and alpha beta will be q. Now we can write alpha to the power 1 by 4 plus beta to the power 1 by 4 is equal to 4th root of alpha to the power 1 by 4 plus beta to the power 1 by 4 whole to the power 4. So this 4 and this 4 will cancel out and we will have the equality. Once we have this inside the square root, we expand this, we get alpha plus beta plus 6 square root of alpha beta plus 4 into 4th root of alpha beta into alpha square plus beta square. Now it's a simple matter of substitution because alpha square plus beta square we write as alpha plus beta whole square minus 2 alpha beta. So alpha plus beta is p and alpha beta is q. We get this as the required value. Question 443 says that if the difference between roots of the equation x square minus bx plus c is equal to 0 is same as the difference between the roots of the equation bx square minus cx plus a is equal to 0, then show that b to the power 4 minus a square c square is equal to 4ab into bc minus a square. So we let alpha beta, this should be backslash beta, it's a symbol, be the roots of the first equation and gamma delta be that of the second equation, then alpha plus beta is equal to b by a, alpha beta is equal to c by a, gamma plus delta is equal to c by b, and gamma delta is equal to a by b. Now from the question we are given that the difference of roots are equal, that is alpha minus beta is equal to gamma minus delta. which implies that alpha plus beta whole square minus 4 alpha beta is equal to gamma plus delta whole square minus 4 gamma delta. We substitute the values, take LCM, and we arrive at the required equality. Question 444 says that if f of x is equal to 0 is a cubic equation with real roots alpha, beta, gamma on orders of magnitudes, show that one root of the equation after x is equal to 0 lies between 1 by 2 alpha plus beta and 1 by 2 2 alpha plus beta, and the other root lies between 1 by 2 beta plus gamma and 1 by 2 2 beta plus gamma. So what we do here is we let f of x is equal to x minus alpha into x minus beta into x minus gamma, where alpha, beta, gamma are the roots. Now we differentiate. So if we differentiate, what you get is x minus alpha into x minus beta plus x minus beta into x minus gamma plus x minus alpha into x minus gamma. Now it is trivial to prove a sign change occurs between the given limits for f dash x, and thus a root lies within these limits. So to actually solve this problem, you need to have the understanding of calculus. So some work is left for you in this question, that how to prove within that limits. Okay. So you take this equation and you try to find out the root, and you will find that it will lie within those limits. So now we move on to question 445. Show that the roots of the polynomial equation x to the power n plus a1x to the power n minus 1 plus a2x to the power n minus 2 up to an is equal to 0 cannot be all real if n minus 1 into a square minus 2n a2 less than 0. So here what we do is we let x1, x2 up to xn are the n roots of the given polynomial equation. If the roots are equal, then we will have following relationship. So this is our equation, okay? So the relationship would be x1 minus x2 whole square plus x1 minus x3 whole square up to x1 minus xn whole square plus x2 minus x3 whole square plus up to x2 minus xn whole square and so on, plus xn minus 1 minus xn whole square, which will be greater than 0. Now once we have this, we can write that n minus 1 into x1 x1 square plus x2 square plus xn square. So you see, x1 has occurred n minus 1 times here. That is what we write. And then minus 2 into x1 x2 plus x1 x3 up to x1 xn, then x2 x3 x4 and up to x2 xn, and finally xn minus 1 into xn greater than 0. Once we have this relationship, we see that this will be equal to n minus 1. There is some computation involved which you need to do. So n minus 1 whole into x1 square plus x2 square up to xn square plus 2n minus 2 into x1 x2 plus x1 x3 and so on up to xn minus 1 into xn minus 2n into x1 x2 x1 x3 and so on up to xn minus 1 xn greater than 0. Once we have that, we can say that n minus 1 into xn plus x2 up to xn whole square minus 2m. So we remove this term and we just consider this. So that will also be greater than 0. Now from the polynomial, we can say that xn plus x2 plus up to xn is equal to minus a1. So here we apply the Vieta's relationship. And x1, x2, x1, x3 up to x1, xn and so on will be a1. Okay. No, this will be a2 actually. It's a typing mistake. This is a2 from Vieta's relationship. So from this we can say that n minus 1 into a1 square minus 2n a2 greater than 0. But it is given that n minus 1 into a1 square minus 2n a2 less than 0. Hence all roots cannot be equal. So see, where was I? Okay. All right. So real, it is not equal. Real, sorry. This should be real. Okay, it is not equal. That's what I was confused. That why this also should be real. Okay, not equal. So see, if the roots are real, squares would be, sum of squares would be non-zero and real. That's why greater than 0. So from this we finally arrived at this result. So there are some typos, they should be A2. Okay. Now we come to question 446. Let D1 be the discriminant and alpha beta be the roots of the equation x square plus bx plus c is equal to 0, and D2 be the discriminant and gamma delta be the roots of the equation bx square plus qx plus r is equal to 0. If alpha, beta, gamma, delta are in AP, prove that D1 is to D2 is equal to A square is to P square. So it's a very simple problem. We let alpha is equal to L minus 3m, beta is equal to L minus m, gamma is equal to L plus m, delta is equal to L plus 3m. So sum of roots alpha plus beta will be minus b by a, alpha beta will be c by a, gamma plus delta will be minus q by p, and gamma delta by r by p. Now it is given that d1 by d2, that is b square minus 4ac by q square minus 4pr, which we rewrite as b square by a square minus 4c by a divided by a square by p square minus 4r by p into a square by p square. So this we can write as alpha minus beta whole square into a square, and then gamma minus delta whole square into p square. Now alpha minus beta is 4d square and gamma minus delta whole square is 4d square. So that gets cancelled, and d1 is to d2 is a square is to p square. Question 447 says that if alpha beta be the roots of the equation x square plus bx plus c is equal to 0, and alpha plus h beta plus h be those of the equation px square plus qx plus r is equal to 0, then show that b square minus 4ac by a square is equal to q square minus 4pr by p square. So here we take the right hand side, we write this q square minus 4pr by p square is equal to q square by p square minus 4 into r plus p. So this q square by p square will be equal to alpha plus beta plus 2h whole square, because sum of these two roots will be minus q by p. And similarly, this term will be equal to minus 4 into alpha plus h into beta plus h. This we can write as alpha plus h minus beta minus h whole square, because if you look at these two, you will see if you take alpha plus h is equal to x and beta plus h is equal to y, then this is x plus y whole square minus 4xy, that is x minus y whole square. So that's how this has come. This is equal to alpha minus beta whole square, which is equal to alpha plus beta whole square minus 4 alpha beta. Then we substitute for alpha plus beta and alpha beta, we get the left hand side. Question 448 says that if alpha beta be the roots of the equation x square plus bx plus c is equal to 0, and alpha plus h beta plus h be those of the equation x square plus qx plus r is equal to 0, then show that 2h is equal to b by a minus q by p. So 2h we write as alpha plus h plus beta plus h minus alpha plus beta, and then we simply substitute for sum of roots and we get the right hand side. Question 449 says that if alpha beta be the real and distinct roots of the equation x square plus bx plus c is equal to 0, and alpha to the power 4 beta to the power 4 be those of equation lx square plus mx plus n is equal to 0, prove that the roots of equation a square lx square minus 4ac lx plus 2x square l plus a square m is equal to 0 are real and opposite in sign. So we see that alpha plus beta is minus b by a, alpha beta is c by a, alpha to the power 4 plus beta to the power 4 is equal to minus m by l, alpha to the power 4 beta to the power 4 is equal to n by l. Now discriminant of the given quadratic equation, that is this equation, will be, okay, this is complicated. So this is 4acl, we square that, 16a square c square l square minus 4a 4 into a square. This should be a square l. This should be 4a square l. Okay, this is wrong. Into 2c square l plus a square m. So this is c actually. This is not x. Okay, this is 2c square. I'll fix this. 2c square l plus m is equal to 8a square c square l square minus 4a to the power 4 lm. And then you simply solve this, you get at 2a to the power 4 l square into alpha square plus beta square whole square. Therefore, roots of the equation which can be computed are found to be alpha plus beta whole square minus alpha plus beta whole square, which are equal and opposite in sign. Now we come at question 450. If alpha beta be the roots of the equation x square plus bx plus c is equal to 0 and gamma delta those of equation lx square plus mx plus n is equal to 0, then find the equation whose roots are alpha gamma plus beta delta and alpha delta plus beta gamma. So we have alpha plus beta is equal to minus b by a, alpha beta is equal to c by a, gamma plus delta is equal to minus m by l, and gamma delta is equal to n by l. So we write the equation whose roots are given, that is alpha gamma plus beta delta and alpha delta plus beta gamma. We arrive here. So this should be x square. There is a typing mistake. And we take the sum. This can be written as alpha plus beta into gamma plus delta. And this we can write as alpha square plus beta square into gamma delta plus gamma square plus delta square into alpha beta. And then we simply substitute. We get a square L square x square minus AB ln x plus b square minus 2ac ln plus m square minus 2 ln ac is equal to 0. So with this, we come to the end of 45th set of problems. There are quite a few typing mistakes, like here, this x square should be c square, and over here, this equal should be real. Okay, so make note of those. And I believe that I could have solved question 444 for you, but take it as an exercise. And if you cannot figure out 444, excuse me, let me know in comments and I will add the full solution in the book. Or maybe in the next video, I'll show you how to solve this. So with this, we come to the end of 45th set of problems. I will fix the typing mistakes here and upload the PDF. So if you want to download the PDF, what you can do is you can come to ashtabak.org and click the second link for algebra book and the third link for trigonometry book. I will refer to trigonometry book when we will study trigonometry. So I have updated this book just today by fixing the errors in the previous videos which we observed. So you can download it, and the link will be in description as well. So I think the problems were, some of problems were interesting. For example, this 445 is quite interesting, and others were basically simple problems. So 444 and 445 are two interesting problems, at least in this case, and remaining are just standard easy problems. So with this, I will end the video, and I hope you're enjoying this playlist. I wish you all the luck for your studies and exams. Thanks a lot for watching the video. I'll see you in the next one with 10 more problems. So till then, goodbye.